In this section, I will introduce about the concepts of quantum mechanics. First, I will explain about the property of light. The prior property of light is the wave nature of light, which means that the light is propagated as an electromagnetic wave. And this light has three different characteristics. The first, interference, second, reflection, and the third, diffraction. And from this nature of light, we can deduce that if the intensity of light is higher than before, the energy of light is also higher than before. However, there is a strange phenomenon which is named photoelectric effect. When the light is projected to the metal, which means that the light has the specific intensity, there is no electron emitted from the metal. So to make the electrons emitted from the metal, we can make the intensity of light much higher than before. However, there is also no electron emitted from the metal. Wrong. So we can change some conditions of the experiment. When the light is projected to the metal with a specific quantity of energy, there are some electrons emitted. However, while we fix the quantity of energy of light and make the intensity of light higher than before, there are more electrons emitted. This result means that the light is also an independent particle which can be seen around us easily. So the second property of light is the particle nature of light, which can be expressed by this illustration. The light as a particle, independent particle, and this has an energy which can be expressed by the formula h multiplied by f. And here, this h is Planck constant, and this f means the frequency of wave of light. So this expression means that a light has dual properties as on wave and particle. And also, we can think of these dualities about the matter. Originally, the matter is a particle, but this is also converted as a wave. When the matter has a mass and velocity v, this matter has the momentum equivalent to m multiplied by v, and also this matter as a particle can be converted to the matter as a wave, which has a wavelength named de Broglie wavelength, expressed by the formula h over mv, and this mv is the momentum of the matter as a particle p. So we can express the energy of the matter E. This is expressed by the h multiplied by f. And here this f is the frequency of the wave as a wave of matter. So this means the duality of matter. And this matter as a wave has the velocity same as the light c, so this frequency f can be re-expressed by the c over lambda. And as I said before, the Planck constant h is equivalent to momentum p multiplied by wavelength lambda. So this can be re-expressed by the p lambda multiplied by c over lambda. So the energy is re-expressed by p multiplied by c. But how can we find this matter as a wave? The tool of this question is Schrödinger's equation, and this expression is the specific case of the Schrödinger's equation as an energy conservation. This Schrödinger's equation is the differential equation, and as the differential equation, when the function is multiplied to the specific derivative operator, it can be equivalent to the some values multiplied by the function, and this value is named by eigenvalue, and this function is named by the eigenfunction. And here, this special case, this operator h hat is a Hamiltonian operator, which is expressed like minus h bar square over 2m multiplied by d square over dx square plus u. And here this derivative term is expressed for the kinetic energy, and this u is expressed for the potential energy. So this Schrödinger's equation can be re-expressed by this formula, and more expressed, and this can be re-expressed again by h bar square over 2n multiplied by d square over dx square psi x plus e minus u multiplied by psi x equals 0. And this is the time-independent equation of the Schrödinger's equation. And this psi x is the wave function, as I said before. So this can be expressed by the Phasor form, a multiplied by e jkx, and this is expressed by a multiplied by e cosine kx. And when we make the square of the psi x, and this can be expressed like the intensity of the wave, and this means this is equivalent to the probability density function. So when we make integrals, the whole intervals of this to this psi x square meant the probability density function, the total answer is 1, because this means this integral formula means the probability. Thank you.